Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. I hope that you're doing well and you are ready for today's show. So today everyone, I hope that you had a great week and you're ready for a great weekend. But before any of that happens, we have the man himself, Ralph Bond. He'll be joining us here in just a moment to talk everything science and technology trends. And he has a number of stories that are a lot of fun, definitely went by the wayside, but let's face it, if you're not a Supreme Court ruling, you probably went by the wayside too. You know, that's definitely been dominating the headlines everywhere you look. But ladies and gentlemen, there are other things happening, we promise, and they're good. So with that being said, let's go ahead and get started with computeramerica.com. That's where you'll find everything, including past shows, future shows, show notes, articles, and of course a special section at the top dedicated to Ralph Bond. If you want to find more of his videos, we have them on a playlist on YouTube, or go over to our site and we have all of his past shows and all the video archives right there uploaded. So with that being said, let's go ahead, bring Ralph on, and hey, we're just going to have fun with it. So as I said before, he's a longtime Computer America contributor, and of course, he is our science and technology trends correspondent, which means he covers everything that science and technology, touch. And that really, that's a wide net, but Ralph does a great job, joins us every Friday to bring us a number of stories that, really, maybe you missed, maybe you didn't, but, they're always fun to talk about. Ralph, welcome back onto the program. How you doing?
Hey, it's great to be back. Happy Friday to everybody watching. And if you're a first-time viewer or listener to the show on the Friday segment that Ben and I do, we cover a wide range of things. I look for fun stories about robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it. Everything is eligible for coverage except for one qualification. It must be uplifting and positive or quirky and fun. So with that said, we've got a great grab bag of stories for you this week.
We definitely do. And especially story number 2, as we were talking about before the show, right. turning the camera into something else. But yes. Yeah, we're going to cover all these. And of course, Ralph, if you want to, I guess you already kind of gave your intro, but show notes. If you want to find out more, check out our site, check out Ralph's site, or check out the description in the video or podcast, wherever you happen to be listening to, and we'll have it all right there for you. So, Ralph, unless there's anything else, I think we can just go ahead and start with story number 1.
Yeah, again, the great reference to the show notes, again, folks, that's going to give you the links. You can dive in deeper if you want. What we do is we collect 4 articles for each Friday that I find that I think are really fun and quirky and interesting and significant. And in the show notes, you can get the links to dive deeper, because we're just going to give you the highlights of each of these stories. So with that said, let's get into story number 1. Solar-powered fuel cell recycles plastic waste and carbon dioxide. And this I got from New Scientist, a story here by Chen Ly. So this is an interesting thing. Ben, you and I, we've talked about all these things of solar fuel cells, taking CO2 out of the air, converting it into fuels. Fine, that's great. We've talked about recycling plastics until the cows come home over and over again, and there's always great innovations. The significance of this story, I'm kind of giving it away up front here, is combining those two things into one symbiotic system, but we'll get into that. Here we go. So what if you could have a solar-powered device that could help remove carbon dioxide from the air and convert plastic waste into sustainable fuel and useful chemicals in what the author says is a double whammy for recycling? I call it a big win-win. So previous research, here's a key point, previous research on solar fuel cells, a technology that uses sunlight to drive chemical reactions that produce fuels have used pure CO2. Keep that in mind, pure CO2. Now, Erwin Reisner at the University of Cambridge and his colleagues, his team, have developed a device that utilizes CO2 captured from industrial sources, think of a smokestack, that kind of thing, or directly from the air around you, filtering out other gases as needed. Wow. And here's the punchline. According to the research team, this is the first time carbon capture and conversion of plastic waste into sustainable fuel have been combined into one system. That's the key. And now what we can do is we kind of dive into what the machine is made of. It's got two compartments. One filters air through an alkaline solution that catches CO2, then converts it into syngas, that's syngas, a fuel that is usually used to make ammonia or methanol. And by the way, syngas or synthesis gas is a mixture of hydrogen and carbon monoxide in various ratios, by the way. And in the other compartment, a solution derived from PET or PET plastic waste gets converted into glycolic acid, a chemical that is commonly used in cosmetics. And I have a little side note here. I'm not going to read through it. You can check it out if you want to come out and get the show notes. We'll have the link and it'll explain everything about polyethylene terephthalate or PET, which is a 100% recyclable plastic. It's really cool. In fact, the beverage industry is really getting into this now to make sure you can recycle your entire Coke bottle or whatever.
Right.
And that's a really cool thing. But let's get back to the machine. Combining the two compartments of the system isn't just a case of creating a two-in-one gadget, because the two compartments actually work together. And I added this comment, they have a symbiotic relationship. That's what makes this machine particularly interesting. So a little bit of detail here. For CO2 to transform into syngas or synthesis gas, it needs to gain some electrons. Now, typically, and Ben, you know this, we've had this covered in many other stories about this subject. Typically, this is done by breaking up water molecules, but the process is energy intensive. That's referencing, for example, people who have these machines that are creating solar based fuels from ocean water and that sort of stuff. So again, typically, this is done by breaking up water molecules, but that process is energy intensive. Instead, the two compartments act kind of like a battery, analogous to a battery, with the CO2 side of the machine being like the cathode and the plastic side of the machine being like the anode, transferring electrons between them. That's the symbiotic relationship. But wait a minute, time out. Reality check. As a proof of concept prototype, the technology is still, the researchers admit, a long way to go before it can be deployed at a large scale. But what a fascinating symbiotic 2-for-1 win-win kind of solution here.
Yeah, it's. I am curious about, and obviously this is all research. I'm curious about how efficient it is because like you said before, they had pure CO2 in this capture CO2. So it goes back to what is better. Like obviously the processing and all the intensive energy and production that goes into the previous kind of equation versus what's kind of automatic solar just captures out of the air. I mean, it's definitely a win-win, and obviously if this worked as well as the other stuff, be great. I am curious about kind of the efficiency, but it's little inventions like these, little breakthroughs like these that one day we're gonna need to get off fossil fuel pretty much completely. It's a finite resource, and we are hopefully as humans an infinite kind of society. So the sun is a great thing to harness, and plastic and all. Like, you're right. This is a perfect win-win, and something kind of going forward that we really need. So it's great to see.
Yeah, and Ben, a good point too is this is a great example of the trends part of what we do every Friday. So great story here.
Exactly. So that's story number one. And story number two, as we kind of said at the outset, adds a little bit of AI into our stories because, you can't have a good technology segment without touting some form of AI. Though this is definitely different, and I like how the artist definitely, ladies and gentlemen out there, if you remember the viewfinder, had a little disc and stuff like that. He definitely made this almost toy-like in its appearance and its usage. So, story number 2.
Yeah, this story is quirky. This fits into the quirky side of things. Whether this is going to go anywhere, or whether it's just sort of a stunt that's interesting and fun. But here we go. Here's the headline: a Danish artist. Now, this guy's an artist. Has debuted an AI camera that generates images using your geolocation data. I got this from a source called news.artnet.com, a story by Adam Schrader. And if you're watching us, and if you're listening to us, please come out and get the show notes so you can see these images. But if you're watching us right now, you can see in the images here, this looks like a regular type of camera, right? A camera that should have a barrel lens on it and all that sort of thing, saying Nikon or whatever. But with this bizarre red appendage on the front, we're going to explain all of that. You'll also see, if you were looking at the show notes, the back of the camera has this display, a rather large screen display. But let's explain what's going on here. So here's the idea. What if you had a camera that takes, or I inserted this, more accurately creates photos using location data? It describes the place where you're at and then converts it into an AI generated photo. So don't think of photo like you normally would, where the camera on your smartphone is looking at, pointed at something, you click and capture an image, right? This is not what's going on here at all. It's this very kind of curious idea. Bjorn Carmen is the name of the guy. His internet-connected camera, named the Paragraphica, uses sensors and geolocation data, including weather conditions, to create a stream of text that is displayed on a screen on the camera's back side, and then converts that information into an image or photo, if you will. Think about that for a second. Uses sensors and geolocation data, including weather conditions, to create a stream of text that is displayed on a screen on the camera's backside, and then converts that information into a photo. Well, it's clever as could be. It's just wild.
Yeah.
The camera it looks like a typical, as we mentioned before, it looks like a typical point and shoot camera, but replaces the lens with a red device described by the photography website Digital Camera World as looking like a TV aerial stuffed where the lens should be. For younger members of the audience, TV aerials were things that my mom and dad used to put up on the roof. And they were like these weird, anyway.
I don't know why the author thought... Yeah, I don't know why the alpha TV aerial would be a good reference point for people, but antenna.
Because Carmen himself, the artist, says, no, this bizarre, and I put in decorative element, is simply a sculpture inspired by the star-nosed mole, an animal that is blind, but visualizes its environment using its snout. And we have a picture in the show notes of this critter. This thing looks like something out of science fiction.
For anyone who's seen, I guess Predator, when he opens up his mouth. Yeah, essentially that, but on a mole. Yes.
Yeah. And so again, that red business on the front, this is just a sculpture, does no function at all. So back to the story here. The viewfinder displays a real-time description of your current location. And by pressing the trigger of the camera, it will create a scintigraphic representation of the description Carmen wrote on his website. Now, timeout, scintigraphic. I said, what is that? And I did some research, Ben. I could not find a reference to photography or anything like that relative to scintigraphic, okay? What I did find were references about its scintigraphy as used in the medical field as a procedure that produces pictures or scans of structures inside the body, including areas where there are cancer cells. And this technology, scintigraphy, is used to diagnose, stage, and monitor disease. So right. I searched and could not find a linkage there. So I'm not quite sure why or how that word is used in this story, but I digress. Here's something interesting, though, as you go on and really get into this thing. Users can control the outcome of the image with 3 physical dials on top of the camera
That's
body.
what I thought was a lot of fun, which if you're watching the video portion, you can see it there. The idea of a physical dial to change the parameters instead of, a drop-down menu or something goofy like that really brings the physical into like a good application, I guess. It's very cool.
It's a great point, Ben, because it's sort of like this guy who's an artist. He's not a technologist necessarily, but obviously he has good technical chops, has made kind of a hybrid between an old school manual world of a manually operated camera and our digital world. And you make a wonderful point that instead of having a drop-down menu, which he certainly could have if the screen were a touch screen, you name it, right? Just like your smartphone. He elected to put these knobs in, which adds kind of a tactile experience to this whole thing. So that's cool. So you have 3 physical dials on top of the camera body where knobs would normally control such things as shutter speed and film speed and so forth. So first knob, Carmen wrote, operates similarly to focal length in a traditional camera lens, but is used to limit the radius in which the camera searches for data. Let that sink in. So it limits the radius in which the camera searches for data about where you are. The diagram of the dial shows that the distance appears to range from nearly 10 feet to infinite distance. Huh. Okay. Fascinating.
You can imagine, and to kind of put that into a practical sense, the first knob that handles distance, Ralph, you can imagine, let's say you're in New York City and, you're near the Empire State Building, you dial the knob, you're going to get a lot of Empire State Building related searches. You expand that enough to include the Statue of Liberty, your picture is going to include the Statue of Liberty, so you're able to fine tune what is included in your radius.
Isn't that something? That's so cool.
Yeah.
And then the second knob, and this also was something that I tried to figure out and research. It says here, the second knob controls the noise seed, SEED, like a seed for a plant, the noise seed for the AI image diffusion. I never had success finding out what noise seed means in the area of imagery or photography, but in the AI image go ahead.
Yeah. And from my understanding, that's essentially the randomness. It's, if you set the noise down to very, very low and you say pictures of watermelon or something like that, and you set that all the way down to low as far as the AI settings go, it's going to strictly look for watermelon related things, and it's going to, try to define it very, very close. If you say watermelon, it's going to pull everything from the fruit to color to clothing to it's going to try to add as many variables as it can to your final image.
Oh, that's great. Well, thanks, because that one threw me for a loop and I couldn't quite figure it out. But then it says here, in the AI image generation process, models add Gaussian noise through which the image emerges. And of course, I had to run out to the web here to get educated on Gaussian noise. Within digital imaging, Gaussian noise occurs as a result of sensor limitations during image acquisition under low light conditions, which make it difficult for the visible light sensors to efficiently, capture details of the scene. And we're all very familiar with that when you try to take low light photos with your smartphone, for example.
So as Gaussian to a regular picture is the amount of light or, the amount that can get in. And then Gaussian, when it comes to AI, is the amount of information and other variables that come in. So there is a similarity there. Yeah.
Yeah, it's kind of fun. And then Carmen described the third knob as a guidance scale, which provides an input for how closely the AI model follows the generated text prompt. Wow. Okay. The hardware Carmen used to create the camera included a Raspberry Pi 4, a single board computer about the size of a credit card, very famous piece of equipment, and a 3D printed housing with custom electronics. The software runs on Noodle and Python coding. All right. So with all of that said, they have a link, and it's in our show notes, folks. So come out, if you're listening to us, come out and get the show notes, because you might want to play with this. Using this link, I tried out their location-based virtual camera. So you can try it out online. You don't have to have the physical camera. You can get the essential experience. So I thought, okay, I'll do that. And if you're looking at the show notes, you can see a morning photo taken at blah, 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 Northeast Jackson School Road in Hillsborough. That's very close to where I live. It talks about the weather is broken clouds, temperature of 14 degrees degrees Celsius, of course. The date is Saturday, the 17th of June, blah, blah, blah. There's a church, elementary school, and a swimming pool nearby. All true. Now, you can actually take, quote unquote, a picture if you're willing to pay a couple of bucks for it. Then for $2, you get 36 pictures, but I was too much of a cheapskate to do it. But I did want to show you what my personal experience was virtually playing with this camera. So clever idea. Does it have commercial viability? I don't know. Could it be a feature that could be added as software only to your smartphone, bypassing the fun of the dials and all that sort of thing? Maybe. I don't know, Ben. What do you think? Where do you think this thing's going to go, or is it going to go anywhere?
It's definitely showing a fun use, because like AI right now, to a lot of people, I mean, you've been messing with AI and creating stories for your grandkids and doing stuff like that.
Yes.
Which is a lot of fun, but like I'm sure you've encountered this, and anyone else who has tried to prompt an AI, it can be a little hard, you can of course just be very vague and just be like, give me a story about a princess and a castle, in a fantasy world, whatever. But if you're trying to get, kind of a more specific kind of prompt, or trying to be more creative than just off the top of your head, it's very difficult to set all the parameters and get everything that you want into it.
Right.
So I think something like this, I know he's doing it as an art project, and he's an artist, and it definitely serves that purpose. Ralph, I'm curious if something like this could be eventually, like a toy. And I know that AI is very unpredictable, and kids are, there's some things that AI generates that kids should not see. But at the same time, I talked about the viewfinder before. This would be almost similar. Kids get to kind of play with AI and kind of understand that, here's the prompt, here's what it generates, and it kind of does everything for them, and they can twist the physical knobs, they can do this, they can do that. If this were, I'm sure it's all custom built, there's no price tag because, he built it himself.
Right.
But if this were to be built into a $20-$30 toy, maybe connected to a Bluetooth smartphone to do all the location services and stuff like that, this would have a lot of application. It inputs a lot of things automatically, which is very, very cool.
Yeah, no, the toy idea, and again, your idea of having a symbiotic relationship with a smartphone, so the intelligence doesn't have to be in the box,
right?
So you can get the price way down. Yeah, I think I could see that. A toy for older children, not necessarily like my 4-year-old grandkids. They wouldn't be able to do this. Or maybe
and I think, Ralph, let's face it, not everyone is as savvy as we are when it comes to technology. This is also a great way to kind of bridge the gap for, for older people that, don't really understand AI or don't really get it and have never really used it. It could also be a fun project for them to kind of, hey, how hard is it to twist a knob and do this and just hit a button and out pops a random picture. So it's a great... It's a great learning tool, I think, for older and younger people, and just a fun toy for everyone else. I mean, it's a very, very cool project. I'm glad that, for an artist, it's very ambitious. So I like that a lot.
Yes, pretty cool.
Definitely. Story number 2. Story number 3. And we can go ahead and talk about this. And this one is, when we talk about electric vehicles, I guess we should also mention the big news this week. Of course, I'm sure, as a lot of people know, the inventor of the lithium-ion battery passed away just 3 days ago.
Wow.
Inventor Dr. John Goodenough. He, of course, won a 2019 Nobel Peace Prize, or a Nobel Prize in Chemistry, for his work developing the lithium-ion battery. And for those who don't know, he was very against money. He was a professor at the University of Texas, and he never applied for a single patent for the lithium-ion battery, which is why you see it everywhere. Yeah, Ralph, I mean, great mind, did amazing things, lived to 100, so I'm sure there's something to be said for earning a Nobel Prize at 96, but Yeah,
how great is that?
He definitely contributed a lot to not just electric vehicles, but to all electronics, because pretty much everything you own has a lithium-ion battery in it.
So true.
Great for the environment to be able to store energy, release it well, and enables a lot of electric vehicles as we know it, which is my way of tying an old headline into today's headline with story number 3. And it all ties in because electric vehicles are getting better and better thanks to John Goodenough's research and building upon it. So
yeah, well, it's a perfect way to build up. And by the way, I didn't know about the passing away of him, and so thank you. That's sad, but also what a great life.
Sad, but I mean, it's a celebrated life.
Wow.
100 years old,
Absolutely.
Can't really ask for much more, and he did amazing work all the way up to the end. I mean, it was great.
Yeah, well, that's great. Well, anyway. That builds right up and sets the stage perfectly for this story. Here's the headline. This new scientific breakthrough could help EVs, electric vehicles, of course, drive 10 times longer before they need a recharge. What? This comes from a website I've recently gotten onto. It's kind of a goofy name. It's called thecooldown.com. But seriously, they do some great stuff. It's a story here by Laurelle Stelle, I guess you pronounce the last name, Stelle. Anyway, so she talks about big news in the world of batteries. Researchers have discovered how to increase battery storage tenfold. What? Okay. We're going to go to Korea for this. Scientists at Pohang, Pohang University of Science and Technology in Korea, found a way to multiply the energy storage of a battery by 10 to create, they say, the ideal EV battery. Sure, that'd be great. The part of the battery that stores power when charging and releases it during battery use is called the anode. Now, currently, most modern lithium batteries use an anode made of graphite. Other materials, like silicon, have a higher energy capacity and would make more efficient batteries. But here's the problem. Until now, researchers have been unable to create a stable battery with a silicon anode. This is because the reactions inside the battery cause the silicon to expand dangerously.
I think expand dangerously is scientific talk for explodes. So yeah, that's a problem to overcome.
That's funny, man. Yeah, instead of explode, it expanded dangerously. That's funny.
Not expanding safely, expanded dangerously. Exactly.
Yes. So, and I'm going to butcher their names, I'm sure. Professors Sujin Park and Yuan Soo Kim at the Pohang University of Science and Technology, together with Professor Jaejeon Ryu, RYU, of Sogang University, led a research team that solved this problem. In other words, how can you make the silicon anode not expand dangerously? That was the problem. They claim they've solved it. They created a binding material that will keep a high-capacity silicon anode from expanding, creating a stable lithium battery with at least 10 times the capacity of one that uses a traditional graphite anode. And in the show notes, I have a picture of the two lead researchers, and that's kind of fun. And the Pohang University of Science and Technology team is one of several working on advancing the world's battery technology. So they're not alone, of course. And Ben, you and I have talked about many of these other research activities. For example, a Chinese company has produced an EV battery that uses cheap, abundant sodium instead of expensive lithium. And I'll stop for a second because there are a number of research efforts throughout the world that are looking at sodium, which is really cool, instead of lithium. Wouldn't that be great? And NASA is developing an improved solid state battery that is smaller and lighter than traditional lithium ones. And another researcher, and Ben, months and months and months ago, sometime last year, we talked about this one. Another researcher is even creating biodegradable batteries from crab shells.
Yeah.
Remember that one?
I do.
That was fun. And in the show notes, if you want to really dig down deep into this, you can go to the university's documentation and announcement about this. I've got a link to that at the end of the show notes for this story.
Yep, and speaking of AI, I opted into, probably erroneously because it's actually pretty annoying. And I don't know if you got the prompt yet, Ralph, where when you Google something, it's like, would you like to generate an AI response to this question? Anyways, according to Google's AI, I was kind of curious, like, how big is the market for lithium-ion batteries? Because they're everywhere, but how many? So apparently in 2018 we produced about 290, and they measure everything in gigawatt hours. So, like your phone might have milliamps, or be able to store X amount of capacity. Right. In 2018, it was 290 gigawatt hours in 2018, and in 2028, 10 years later, it's expected to be around 2,000 gigawatt hours, which means you're seeing almost a tenfold increase in that production, or in that demand for batteries, so a tenfold increase over the next 10 years, and that's year over year. So, in the year 2028, we'll produce 10 times as much as we produced in 2018. So clearly, there's a huge demand for lithium. The sources of lithium are running out. There's it's a pretty abundant source, but for as much as we depend on it, it's not that abundant. Finding alternate solutions is going to be critical. And then, Ralph, the problem is it has to be better, it has to be better, higher storage density, cheaper. It has to hit all the marks that lithium ion kind of does already, which sodium we've heard a lot about. Fingers crossed. I'm hoping that's a trend that we hope, that we really get to break through. The sodium ion battery really steps up. You're right, Ben. If we could, the holy grail, one of them could be the combination of this technology we just talked about, the silicon anode, combined with the sodium-based instead of lithium-based battery. And if we can pull this off to the races, all of a sudden EVs, everything, cars would be less expensive, on and on and on. You could have large capacity freight trucks, all these kinds of things that we've talked about before. Be very cool. You know what would actually be one of the best things if silicon or sodium, either one of them kind of take off. Ralph, I don't know how many people know this, or people should know this. When you're transporting cars, electric cars, if you're transporting phones, if you're transporting whatever, you're not allowed to fly them on planes, because the higher altitude can cause them to expand, and that can cause fires. So anything that's shipped internationally is shipped through shipping lanes, and which is a little bit slower and a little bit less efficient, I assume, or actually they're pretty efficient, but still. Any of these technologies are safer. They won't explode, won't cause fires, will be, more waterproof. There's so many benefits. Lithium-ion battery has done amazing things, but the next thing is going to be so much better for society at large. And I'm really looking forward to it, because I don't know about you, Ralph, but I've been hearing about new battery technology for, ever since the lithium-ion came out. So hopefully soon.
So true.
Hopefully soon.
So true, yeah. And again, this story we just did is a good example of the trends part of what Ben and I do every Friday, because we're not saying this is here now. What we're giving you is a glimpse into the future, we hope.
and to another point that you continue, or that you make or try to make, is that research happens all over the world. These people were from South Korea, right? Yeah. I assume South Korea. It said Korea. I assume South Korea. So these researchers, So these researchers, the North is preoccupied with nuclear research, but so South Korea is working on this, and trust me, there are research labs all over the world tackling the same problem. But still, very cool. Story number 3. Story number 4. And this is another technology that, when it comes to when it comes to medical technology, which you always love to end on, when it comes to medical technology, 3D printing has been a huge topic of conversation for organs and for inside the body, for obvious reasons. We like our organs, we like them to work, and the 3D printer has always held a certain fascination for surgeons, because hey, if you could just fix something very niche and very form fitted to you, that would work great. Story number 4 kind of combines a technology with not the big 3D printer, but the little handheld ones, Ralph. I'm sure you've seen them. That you can make little sculptures with them and stuff like that.
Sure.
That technology may be in the body. So story number 4.
Yes, this is a great way to end the segment. Again, as Ben said, I'm a devotee. I'm obsessed with medical technology news. And this headline's fun. Handheld, that's the key. Handheld bioprinter prints tissues and organs within the body, and not only within the body, but actually on the surface of the body, as you'll find out here. This comes from a great website called techexplorist.com. And a story by Ashwini Sakharkar. I butchered the name. Sorry, folks. Sakharkar. Okay. I tried. And there's some great images in the show notes, which Ben is showing you as well. And great captions for each of these images that explain what's going on here. But let's get into this. Over the past few years, 3D bioprinting, which Ben was talking about, has been widely applied in the construction of many tissues and organs, such as skin, vessels, hearts, etc., you name it. These engineered tissues and organs are used to understand disease formation and progression, or to develop biological substitutes to repair or replace damaged organs. That's what we're talking about, this broad field. Now, despite significant advances in this area, currently used in situ, that's Latin for in place, bioprinting technologies are not devoid of limitations. And I need to kind of drill away on this in situ. Usually you hear about this in archaeology. For example, when they discovered King Tut's tomb, okay, it was in the location where it was originally. That means in the original location in situ. So in this context, they're talking about bioprinting at the site of the problem in the body, whether it's on the surface of your arm or inside and so forth. That's what we're talking about, okay? Now, most devices are only compatible with very specific, if I could say it, specific types of bioink, while others can only create small patches of tissue at a time. In addition, their designs are often complex, which makes them expensive and limits their application. So that's currently where we're at. Now, in a breakthrough study, a research team from the University of Victoria in Canada developed a handheld in situ bioprinter. Wow. The new device has a convenient modular design that allows the printing of complex biocompatible structures, meaning the compatible with your own body, right? Mm-hmm. The new bioprinter addresses key limitations of previous designs, including the ability to print multiple materials and control the physical chemical properties of printed tissues. This is really, wow. That's all I can say. And it goes on to say
and the pictures aren't really for the faint of heart. From the captions, they're kind of pigskin. So if you're kind of freaked out by that, right, kind of be careful. But still, to see the pictures themselves, man, it's really incredible seeing them essentially fixing skin and fixing the tissue underneath skin, which you can imagine for people would be very important.
Yes. Yeah, you're right. And once again, it tells us our little piggy friends are, well, pig skin is, if I understand this correctly, is very close to human skin. That's why the researchers use it so much. In fact, pig hearts are used for transplant attempts and all that kind of stuff, because these little piggy, that makes you stop and think about, should you really be eating bacon and pork chops? They're close. That is a moral and ethical dilemma I'm not prepared to take on this morning. So yes. Okay. Anyway, the ergonomic design of the handheld bioprinter facilitates, the shape-controlled biofabrication. I love that, of multiple component fibers with different cross-sectional shapes and material compositions. That's very geeky. The pictures kind of give a better illustration of that. The handheld device has multiple bioink cartridges, each independently controlled by a pneumatic system. Therefore, the device operator has ample control over the printing mixture, which makes it easy to create structures with the required properties for each wound or situation or patient need. Well, wait a minute, timeout. What is bioink? Well, bioinks are materials used to produce engineered artificial live tissue using 3D printing, Ben, as you mentioned at the outset. These inks are mostly composed of cells that are being used, but are often used in tandem with additional materials that envelop the cells. The combination of cells and usually a biopolymer gels are defined as bioink. And I've got a source for this information if you're interested in that. The device also includes a cooling module. Get a load of this. Also includes a cooling module and a light-emitting diode photocuring module, that provides additional control. This thing's so out there. It's like something the medical team on the Star Trek. This is what they would have, right?
Yeah, the medical team on the Star Trek, if they needed to install a little light bulb for some reason on the skin. But I guess they're showing because, skin and muscle and tissue, it's not just to, kind of provide the tissue. It needs to be able to, let's say, conduct electricity because, that's how our skin kind of communicates with everything. So, for it to be complete, it's not just a patch. It's actually going to be part of the skin. Very important.
Yeah, cool. And it says here, the handheld in situ bioprinter will pave the way for a wide variety of applications in regenerative medicine, drug development and testing, and custom orthotics and prosthetics. Very cool. The portable bioprinter may help physicians match a patient's tissue anatomy with greater accuracy and convenience, thus enhancing the functionality and aesthetic of the bioprinted construct, whether it's a skin or an ear or whatever it may be. Now, according to Professor Mohsen Akbari from the University of Victoria in Canada, he says, quote, in situ bioprinting is suitable for repairing large defects caused by trauma, surgery, or cancer, which requires large-scale tissue constructs. In the long term, he goes on to say, this technology can eliminate the need, wait a minute, in the long term, this technology can eliminate the need for organ donors while also lowering the risks associated with transplantation, allowing patients to enjoy longer and healthier lives. Wow. What a great way to end this show, right?
Yeah.
Talk about positive way. I love it.
Yeah, the ability to just fix your organs instead of waiting for someone else to no longer need their heart or their lung or their kidney or whatever it may be. Just fix yours or print a new one. That's always been the hope of 3D printers, and I love that you cover bioink because it's just what it sounds like, ink that works with your body.
Yes.
I will say that this story definitely has, as we kind of go out here, that this story definitely has a little bit of resonance with me because my mother just went for the first time in a little while, went and got those, those growths and moles checked, that one develops over time. And, like everyone else, she kind of let things fall off the table during COVID, and post-COVID, she finally went to go see a dermatologist. And Ralph, as she described it, the dermatologist was not skimpy with the margins and dug holes. So I could imagine
the Mohs procedure.
Yes, exactly. They want to be safe, which is great. But you can imagine that if instead of those little holes, and if they're big enough, they put one or two stitches into them, whatever it may be. Ralph, imagine instead they immediately fill them with something like this, and they're able to kind of fill those wounds, cover them, and then instead of having scars or all over the body or something like that, hey, you just have perfectly regenerating skin. There's a lot of promise here, and this could affect a lot of people.
Absolutely. No, you're right on target. A Mohs procedure, folks. I'm a skin cancer guy myself. I had a Mohs procedure that was about the size of a quarter. They had to stitch it all together. It was very tight. So if you could just bioprint my tissue there, great.
Yep. Hey, stuff like that is definitely possible. So, ladies and gentlemen, the music means that we are about done for today. If you want to find out more, computeramerica.com. We'll have a link to Ralph's site. We'll have a link to all the show notes, the articles, everything and more. Ladies and gentlemen, until next time, thank you for tuning in, and we'll catch you here next Friday. Everyone, have a great day. Thank you so much. Bye-bye.